Nicholas, a match made for future-proofing infrastructure. What are you up to with Siemens?
Yeah, look, first of all, I love that tagline. It's a great representation of the partnership that we have, Siemens and Bentley. So first of all, future-proofing infrastructure, what does it mean? So infrastructure is under immense pressure. If you think of climate change, if you think about the need to secure our provision of energy, there's a ton of investments that are required. The stakes have never been that high for infrastructure, right? So we need to make sure that we design, we build, we operate better infrastructure. And a key way of doing this is before you actually build that infrastructure, before you operate that infrastructure, is to model it and then to simulate what will happen, right? And this is where the concept of a digital twin plays in our sector. The ability to create a digital twin of the infrastructure you want to build and then use it for simulation purposes so that you can have a better understanding of how that infrastructure will be able to take on some of the pressure that is coming from the climate crisis.
More electric vehicles being plugged in, whatever.
There you go, exactly. And now, understanding that infrastructure itself can play a negative role when it comes to the carbon footprint, making sure that the way the material you're going to use, everything you're going to use in order to build it is as limited carbon footprint as possible.
And you mentioned the digital twin, right? And the digital twin means many things to many people, but you called out, you had great comments around dark data, high fidelity data, the integrating it with the workflows, and cybersecurity, because critical infrastructure is a critical infrastructure. Where do you see digital twin technology heading?
Yeah, well, so first of all, when you think of the infrastructure sector, one thing to realize, it makes it a bit specific, right? It's a very, very file-centric a group of organizations, right? You think of architects, think of engineering firms, their main deliverable is going to be a file. It's going to be an architecture plan, it's going to be the model of the building that needs to be built, or the model of the bridge, or etc. Now, what's going on is, unfortunately, a lot of the data that is created along the way, when these files are being created, goes stale. It becomes dark. So we estimate that maybe 95% of the data that has been created is not used, is not accessible. So here's 95%. 95% is dark data. So the problem is the people need to make the decision about the infrastructure that needs to be built on the design or during the construction or during the operations. You could argue or aren't they informed. And what we need to do is to make sure that they are as informed as possible in order to make the better decision that will lead to better outcomes. And this is where the digital twin technology kicks in. It's the ability to reach the data that is in all of these files, to surface it, to align it with engineering level of precision, to be able to use it for engineering workflows, whether it's during design or construction or operations. Right?
Okay. And if I may, I suppose the other thing you mentioned was you showed us examples of what you're doing with Siemens here in Berlin, the iTwin digital twin example. Incredibly impressive technology and your solutions and whatever. For a lot of companies looking at that, they look at that and go, God, that's incredible, how do they do that? But they'll go, but where do I start? How do you help people along that journey?
I mean, it is truly impressive and awesome infrastructure that we were showcasing today, between the Siemens Square as a district or ITER as a fusion reactor. Now, digital twin is actually very easy to start using as technology. You can start using it by simply taking pictures of an existing infrastructure asset, and from those pictures we can derive a 3D model. And once you have that 3D model, you have the basis of a digital twin, and you can overlay additional information.
You can get information from IoT or whatever, right?
That's right. If you're a smaller, engineering organization, then you can simply upload a BIM model into our digital twin platform, and then there you go. You have a digital twin, and you can continue to overlay additional information. So it is extremely easy to start with. It can be used for awesome infrastructure, like we've seen with Siemens Square and ITER, or much simpler, much humbler infrastructure.
And I think Peter Corton mentioned it as well today in terms of it's all about the next stage of digitalization, right? So you start off with gathering the data, putting it in the digital twin, and we will get to a path for the metaverse in the future, right?
We will. So one thing to know is we're not talking about changing any of the workflows, any of the ways that people, the firms are currently working. No, they continue to work the way they've done it. We just make them more efficient, more effective doing these workflows using the digital twin technology. Right? So continue to do what you were doing before. You create files. As you create files, we create digital twins, and then you can use that digital twin to be more precise when you do design reviews, when you collaborate with others, when you want to validate the design in a more advanced way, when you want to deconstruct the model to understand the different phases of the construction. You can do all of that using digital twin.
No, it's fascinating, and to see the capabilities, the art of the possible that you're bringing to the market is it's impressive. Hey, I wish you well.
Thank you very much.